Hi, myself Diksha, and in this video, I will guide you through the task 3.1p of Embedded Systems Development. The objective of this task was to design, build, and test an embedded solution using Arduino Nano 33 IoT and a light sensor. The problem scenario was based on a terrarium that requires around 2 hours of sunlight each day. The goal was to measure sunlight exposure and use IFTTT to send notifications whenever sunlight starts or stops. The, the video will provide all the information that we need to do the task successfully. Moving further. Before moving to the task, I would like you to explain two key points, that is IFTTT, which stands for if this then that. It is a free cloud service that allowed automated actions whenever specific conditions are met. In this project, it is used to send notifications about sunlight exposure. The light sensor is the hardware component that measures light intensity in lux, giving Arduino the data it needs to determine whether sunlight is present or absent. Moving on further, here is a demo video, but before that, I would like to explain the code that I used to make this function work. And I started the code by adding some libraries. First of all was Wire for I2C communication, and then Wi-Fi Nina for Wi-Fi connectivity, and Arduino HTTP client for sending HTTP requests. And I also downloaded another library for light sensor to capture the light readings. So in the beginning, as we can see in this video, in the beginnings, I added the Wi-Fi credentials, and then I named the event as sunlight start and stop. And I also put a light threshold of 500 lux to determine whether sunlight is present or not. And after in the loop function, the Arduino continuously reads the light values. If the reading is above the threshold, it triggers the sunlight start event. If it drops below the threshold, it triggers the sunlight stops event. And while sunlight is present, the system also calculates the total duration of sunlight. And finally, the trigger IFTTT function sends an HTTP request with the event name and measured value, which activates the corresponding automation in IFTTT. Before this video, I would like to show the hardware settings of the sensor. As we can see in this setup, I connected the ground part of the sensor to the ground part of Arduino Nano 33 IoT and the VCC to the 5-volt supply, and I connected the SCL and SDA wires to the analog pins A5 and A4. And let's move on to the demonstration of our system working. Here the code is ready source. And let's see this video. Here, let me move it up further, as here I'm showing the code. And this is my setup. As we can see that the Arduino Nano 33 IoT and the whole hardware setup basically is connected to my laptop. And these are my connections that I made. And these are the values that the sensor is storing and showing on the Arduino IDE. And as you can see, when we put light on the sensor, we can see and when we put the light on the sensor, we can see there is a special message shown that congratulations, you have fired the sunlight start event. This specifically message shown to us when the light reaches above the threshold level. And that's all concludes my task, as the task was all about this. And a notification is also sent to my phone about this event information through IFTTT. And this is the system in action, and this was the IFTTT response that I got back. And so that's all concludes my knowledge about task 3.1c. Hmm. 525. So, to summarize, my video shows all the hardware setup, software setup, and the working video of the setup. And this all completely concludes my task 3.2c. Thank you.